Hey folks, welcome to my channel Number Pen. So there we have the problem on our screen. Integrate the following with respect to x. We have sine 4x divided by sine x, right? So what we've been given is dy by dx and we've been asked to find what is our y. So let me write down my y using the integral symbol. Means my y is integral of the given expression, right? And the job in hand is to reduce the expression what we have to a much simpler expression whose antiderivative we know from first principles, right? Looks like we do not have a very simple expression in hand, and looks like we will have to do a lot of simplification here. So I have a sine 4x in the numerator and I have a sine x in the denominator. So the thought process has to be, how do I go about eliminating the sine x in the denominator, right? And this is just one of the ways of doing it. There could be multiple ways of doing it. And if you have found out an easier way, please do comment in the description. So I know that my sine 4x, for a minute, I'm not going to touch y. I'm just going to touch the expression what I have, sine 4x by sine x, right? So I'm going to write this like this. And I know that my 4x can be represented as x plus 3x, right? And I retain my sine x for now. And then my sine 4x, which is written as sine of x plus 4x, I can rewrite this as sine of x cos of 3x plus cos of x sine 3x, right? I use the sine of a plus b formula, which is nothing but sine a cos b plus cos a sine b, right? So this is what I have. And then I know that I can further decompose the above expression, right? I have sine x cos 3x plus cos x sine 3x, the whole divided by sine x. And when I decompose this, I get sine x cos 3x divided by sine x plus cos x sine 3x divided by sine x, right? The second expression, I'm going to use an identity which we learned in trigonometry, which is nothing but sine 3x equal to 3 sine x minus 4 times sine cube x, right? Why am I using this particular identity? Because if I use this identity, I know that I can cancel out the sine x above, right? And let me see what I get using this particular expression. I can cancel out my sine x in the first expression. I get a cos 3x, and in the next one, I have a cos x times. I know that my sine 3x is now 3 sine x minus 4 sine cube x. And when I divide that by my sine x, what I get is 3 minus 4 sine square x, right? I hope you folks are with me. I know that I'm skipping one of these steps, right? So this is what I have, and I know that I can do a little more of simplification here. Cos 3x plus 3 cos x, right? Minus 4 times I have sine square x cos x, right? I can rewrite this as 4 cos x into 1 minus cos square x, right? And then when I rewrite it in the next line, I get cos 3x plus 3 cos x minus 4 cos x plus a 4 cos cube of x, right? I retain the cos cube for a minute. I know that I can cancel out my cos 3x minus cos x plus 4 cos cube of x, right? I'm going to use a very similar identity here. And what is that? My cos 3x, what is it? Is nothing but a 4 cos cube x minus 3 cos x, right? This is an identity that I'm expected to remember. And with this, I can re-express my cos cube x, right? So I can write my cos cube x as, go to the next line, cos 3x minus cos x. My 4 cos cube x is nothing but cos 3x plus 3 cos x, right? I hope you folks are with me. I'm doing a little bit of rearrangement using this particular formula. Let me highlight this in yellow, which is nothing but a cos 3x equal to 4 cos cube x minus 3 cos x, right? So let me go to the next line. I know that I more or less have what I want. I have 2 cos 3x plus 2 cos x, right? So the expression sine 4x the whole divided by sine x is nothing but 2 times cos 3x plus cos x. There are multiple ways of doing it. This is just one of the methods, right? And I have done this using the trigonometric identities that I'm familiar with. You might be familiar with multiple other identities. For example, you could more quickly arrive at this using the sum product formula, right? So I have a 2 times cos 3x plus 2 cos x, right? So that's the expression that I have for the given function. Now I go back to my y. I know that my y, which is integral of sine 4x by sine x dx, can be rewritten as something like this: 2 times integral of cos 3x plus cos x dx, right? I go to the next line, I apply the sum rule, nothing but y equal to 2 times integral of cos 3x dx plus 2 times integral of cos x dx, right? From here on, it's quite simple. I have y equals to 2 times, this is nothing but sine 3x by 3. And if you're not quite familiar with this, I would request you to take a look at some of my previous videos. Also go through the description in this particular video. How do I solve the integral of a function f of ax plus b type when I already know the integral for f of x, right? Plus 2 times sine x plus c, right? So there we are. That's the final answer for this particular problem. Let me highlight this in pink. I hope you found my content useful. Please do subscribe to my channel and support. Thank you.